Hello everyone, in this video I show you the use of our BRC Power Optimizers. Maybe you had it in the past that you had a customer with a really difficult roof because of shading, because of different inclination or orientation, and the customer said, hey, this roof isn't suitable for photovoltaic at all. If you had in the past a situation like this, we have the best solution for you in the future to make also these roofs suitable for photovoltaic with our optimizer. In order to show you how it works and what the problem is, I now show you a system with a shading problem and explain what the optimizer is doing there. So at first, let me show you the problem and what the optimizer is doing by itself. In order to show you that, I have here a system out of 7 modules in a series connection. And now we see what the modules are doing. In the first scenario, we have no shading problem. So each module can produce the maximum amount of power. Each module produces some kind of current. In that case, we will say it produces 10 amps. And also on each module, you have a voltage. In this case, we say we have a voltage of 40 volt. This module is now able to produce a power of 400 watts. Because of the serial connection, the current is the same everywhere. So when this module can produce 10 amps and all the other modules can produce this 10 amps. So we have this 10 amps in the whole string. So when we look at the summary of all the power of each module, you have 400 watts each. And then you can say the system produces a power of 7 times 400 watts, or in that case 2800 watts. Here you can see it also on the inverter graphics. When you see the current and the voltage, you can see that the inverter now is looking for the maximum power point. In order to do that, it increases the current for the best current you can have. And we will see that the best current and the best voltage in this scenario is right here at this maximum power point. And this is right on the situation where we have this 10 amps in the whole string, and also the voltage of the string of 280 volt, 40 volt each module. Like we have seen in the scenario before, we hadn't the problem. Now we see in this case we have a tree right next to your PV system. Now let's say it is evening and this one tree is now shading one of the modules. What will happen now? You know, each module, the amount of current the module can produce depends on the irradiation. And so this one module can now not produce this 10 amps any longer. It can, let's say, produce just 5 amps in this scenario. It wouldn't be a problem because now this one module can produce 200 watts still. But the big issue is the serial connection of all the modules. So this 5 amps is not only on this one module, this 5 amps is in the whole string. So the whole string can now just produce 5 amps, or in other words, each module can produce just this 200 watts any longer. So the power of the whole system in this scenario would be that we have our 7 modules producing 200 watts each. So we have a maximum power in this system of 1400 watts. We also will see that in the graphic, because now the inverter once again tries to find the maximum power point. It started by raising the current, but it sees there is one module that is just producing 5 amps any longer. So the new maximum power point is now in this point here, where we have this 5 amps and the voltage of 280, or in other words, we have this 1400 watts in the system. So I now showed you one way the inverter can work. New inverters have so-called global MPP tracking, and they act differently. If they detect that one or more modules can't produce the current they want, they would activate the bypass diodes. In each modules today we have bypass diodes installed in the junction box of the modules in the back. So in that case, the inverter would increase the current even more than these 5 amps, and this one module would get bridged out of the system by a bypass diode. Now this one module produces no energy for the string any longer. We have 0 watts from this module. But the good thing on the other side is that this one module doesn't slow down all the other modules. So the other modules are now able again to produce this 10 amps. So in this scenario, we would have still left 6 modules that can produce this 400 watts. We have a power of the system of 2400 watts in this case. But this one module wouldn't produce any energy. So let's see at the graphic again what happens now. It's like before, the inverter starts by increasing the current and looks for the MPP. He finds there is at least one module that can produce just this 5 amps, but then it increases the current over this 5 amps, and we see that now the voltage decreases a little bit by the bypass diodes. It decreases by 1 modules. And then by decreasing the voltage, now the inverter is able to increase the current back again to the level of 10 amps. And now the inverter finds 2 maximum power points. One at this point we had before, but now a different maximum power point, and this is this one, with now the current of 10 amps again, but now just with a string voltage of 240 volt. And so we have the power of 2400 watts in the whole system in this scenario. So if you look just at the power, we see that this scenario is much better than the one before. But we have still energy left that is missed right now. We saw before that this one module could produce 200 watts, and this energy is lost in this scenario. Even worse, it's not just lost, it will be transformed into heat on this one module. So over time we have hotspots here on this one module. And over time this one module could be destroyed because of these hotspots. So we have still a problem. We have still power that is lost, and we have still this problem with the module destruction by the hotspots. And right, this is the point where we need an optimizer like the optimizer from us. And now we will see what happens if we install an optimizer right to this one shaded module. Now let's see what happens if we use an optimizer by BRC. With the BRC optimizer, the good thing is you just need one optimizer in this scenario, so you don't need it everywhere, but just on this one shaded module. So we install now the BRC optimizer right on the one problematic module. And we now divide the electronic world into 2 worlds, a world on the side of the module and the world on the side of the spring. Like we saw before, we have here on the side of the module, we have this 40 volts, but just 5 amps because of the shading. Yeah? And the problem is the current. Our optimizer now detects that the inverter wants more than this 5 amps. It wants, in this scenario, 10 amps for the whole string. So we detect a difference in the current and now start to optimize. Optimizing in this case means we decreasing the voltage to increase the current back to the level of all the other modules, or back to the level the inverter wants. So in order to increase the current from 5 amps to 10 amps, we have to decrease the voltage from 40 volt to 20 volt again. So now the good thing is, on the side of the string, we have this 10 amps everywhere. So all the other modules can now produce also this 10 amps again. But this one module hasn't to be bridged out of the system via bypass diodes. The rest amount of energy of 200 watts is still in your system. So let me see what we have in the power level of the whole string, right? We have these 6 modules that can produce 400 watts. And we have this one module that can just produce this 200 watts. So in the summarize, we now have the maximum power of 2600 watts in the system. So on the one side with the BRC Optimizer, you have now the maximum amount of power that can possibly be in this situation. And the next cool thing is, this one module doesn't get bridged out of the system. So there is no energy left that gets transformed into heat. So you have no danger of hotspots any longer, and the modules have no danger of being destroyed any longer. Now I've shown you the use of BRC optimizers if you have a system with a shading problem. But it's not just useful for shading situations. In general, you can say you can use optimizers if you have a string with different irradiation of some of your modules. So of course, in a case of shading, but also if you have a roof with different orientations, different inclinations, where you have to combine all the modules in one string. In that case, you can also use optimizers. So easier to say you have a difficult roof, yeah? Then with a smart planning of your string and an optimal use of your optimizers from BRC, you can make all these roofs suitable for photovoltaic. So thank you everyone for your attention. I hope this video was interesting for you. If you have questions further, you can just leave a comment below, or you can go on our website and join our free webinars. There we can talk more about and answer all your questions you have.